reason we decide to choose PICC because some of our members went before for a field trip and amazed by the architecture. For data gathering, we use email and call interview and online research due to the pandemic. The Putrajaya Convention Center is situated inside the Putrajaya Federal Administrative Center, Precinct 5. This construction finished on April 2003 and this building cost approximately 600 million ringgit and has a total area of 135,000 square meters. This building is designed to host world-class government-to-government meetings such as the OIC 10 Summit. It is an indicative of the development and the success of a modern Islamic Republic. Tun Mahathir announced his retirement upon the completion of this building and the summit opening. This building is designed by Hijaz Kasturi Association. PICC's concept encourages visitors to enjoy both architecture and nature. The spaces are lined with greenery and welcome nature features that contribute to the spatial experience. As for the form, the circle is the most powerful sign of abstract unity. The site is shaped like a rounded diamond and reminiscent of the Pending Perak, which is a traditional Malay warrior belt buckle.
Okay, so for the next topic, we were talking about the key features and the building system that we found in PICC. So based on the main topic, we will go to the building structural system and use of the building material. So first one, for the structural system, is using the long span roofing structural system in PICC. Also, it had column-free structural system by using the radial arms together with compression ring beam and also the grey ledge beams. Next will be about the complex roof structure that over the plenary hall, and it is conceptualized as a spine truss spanning across the north-south direction from this building. And last point is about the construction and structural system above the ground floor of PICC consisted of composite columns, structural steel frame, and reinforced concrete composite slab with the shear connectors. So if we look more detail in its roofing system, is using a copper roof and is eye-catching. So why I mentioned so many times about the roofing system, because one of the most integrated design they can found in this building is about the roof. So it's using copper roof and it's eye-catching. So, and also why they're using this copper, one of the reasons is because it had excellent corrosion resistance compared to other material. Also, the form of the roof is a unique combination of enclosed protection and also the soaring flight. So actually, because of using copper, then there are no need to maintain all the time. Plus, this roof actually is not allowed to, it cannot be accessed for maintenance. So copper will be one of the best way for them to build this roof for this kind of building. So this also can help to reduce their costs and also for the natural resources. Another one is about this roof lifted at the sides, creating the block overhangs over ranking glass facades. So you can see the pictures below. You can see how it shades for the building, and this prevent them for more glazing from the sun. So back to the copper. So the copper-based material is suitable for a big roof structure because it is light and when it is fully supported. So in conclude, is a best way to use the copper from the aspect of corrosion resistance, durability, thermal expansion, maintenance, weight, lining protection, antimicrobial, and cost effectiveness. So next will be about the integrated design solution. So it will go more detail for the building materials in this PICC building. First one will be the membrane type seamless roof, which is able to handle the additional stress from the temperature fluctuation as the tension is spread across the entire rooftop evenly, and is able to stretch over the three-dimensional roof form. And for extra information, there are a clerestory between the roof that was created to bring in some light from the sky above. So actually this roof is not totally enclosed. Last point is able to fit into the uncommon roof form and is solar reflective and vapor permeable. So it's quite suitable for this building since it need a long span structure system. So this kind of roof is very easy to be built based on the typology and based on the situation. Moreover, for the second one and also the last one is about the glazed walls with the double glazing system. I think this is quite common, but I will brief some of it. So this kind of integrated system panels such as the glazed walls with a double glazing system in PICC is like consists of 2 layers of glass with an A gap between them. So it can create nearly twice the insulation compared to the single glazed unit, and is able to enhance its acoustic performance to its maximum potential also. So in PICC is used, actually this kind of glass is used to enhance the acoustic insulation that wrap around the upper galleries inside. So for exterior design, it also had the slopes at 50 degrees and is louver to prevent the direct solar gains. So last point is able to control the glazing and the solar gain nicely. Even the building skin is mostly using the glass panels as well. So that's all for the building structural system and also the use of building material.
So next, let's move on to the space planning and programs. So PICC building programs, they have 2 main space, which is the plenary hall. It is designed for large gathering, and this hall sit up to 3,000 people and has a podium stage. And then next, the Perdana hall. It features a large kitchen that seat 3,000 dinner at one time, and have 2 unity halls that can be separated to host seminar, exhibition and so on for up to 2,000 people. And then the PICC include 2 main entrances on the ground and mezzanine level, as well as a 2-level basement car park with 1,200 parking spaces and lift access to all floors. So this is the floor plan from the mezzanine level until 3rd floor. Next, let's move on to the form and facade design. So the PICC building form and facade are inspired by 4 categories. First is the pending perak. The building architecture is inspired by the form of pending perak eye, which is a silver Malay royal belt buckle, and then it is a Malay contemporary architectural style. And then next, the roof structure is inspired by the folded origami. Then lastly, the wow. So the wow is to show that the people of Malaysia rich with the culture heritage, as well as the fact that PICC is going to show that they are the landmark of the country and the region. So this is the PICC for front elevation. We can see all the features.
Moving on to the acoustic features, acoustic plays a part in achieving the occupant's comfort. The acoustic features applied in the PICC building include sound reflectance, absorbance, diffusion, and amplification. The building tends to achieve ideal sound transfer through sound reflectance, but the architectural designs fail to provide a good condition for the sound to be reflected. Both the ceiling and room shape of the plenary hall reflect sound waves to a concentrated part of the hall only, which you can see in the picture, the central part of the hall. It causes other parts of the audience seats to be deprived of similar sound clarity, and reflectance of sound from all directions to one concentrated part create unwanted echoes. To tackle this, the hall is equipped with good sound absorbance materials such as the fabric-covered interior walls, which allow sound waves to pass through the non-sound reflective fabric to reach the absorbance materials at the back that helps to eliminate sound reflectance. Besides, on walls and seat dividers, the decorative timber planks with stepped surface profile provide ideal sound diffusing surfaces to scatter incident sound waves in all directions, maintaining the ambience in the hall. On the wall as well, there are timber perforated acoustic panels in the shape of octagon that fulfill both sound absorbance and diffusing requirements. The edge of the panels reduces the intensity of sound by scattering it over an expanding space, while the tiny dents allow sound waves to penetrate through and be eliminated by the absorbing materials behind. Lastly, sound amplifying devices are used to disperse sound consistently and steadily over the large hall area. Sound amplifiers, as indicated in red on the left picture, are placed above stage to increase sound volume and power, while the wall-mounted supplemental speakers, as indicated in blue, were installed around the walls to ensure consistency of acoustical experience from all sections of seats.
We will continue to part 3, which will include an analysis and discussions on building safety, accessibility, performance, and integrated design. The first analysis topic is on the Universal Design Implementations and Initiative. The Caring for Society program in Putrajaya promotes building planning that improves securities and a barrier-free environment for everyone. To fulfill the design goals, the built environment must be accessible to all users, including persons with disabilities. The PICC has been established to fulfill the following barrier-free legislations and standards. We noticed that some modifications to this requirement has been made after the building began in 2001. In this study, we will assess the revised regulations or standards in order to make any necessary improvement or suggestion for the future amendments. This study also looked into Universal Design Principles and the Person with Disability Act 2008. As part of the data gathering for this analysis, the PICC spaces are all measured and graded accordingly to the regulations. Based on the observations of those facilities, checklists of design requirements derived from Malaysian Standards for Accessibility, UBBL 1984 for fire protections, and Universal Design Principle are studied. The findings show that PICC provide good accessibility to public with a score of 61 out of 75. The design of tactile paving, which is not supplied at the exterior area of PICC building, is one of the key weaknesses in terms of accessibility discovered in the study. There are two types of guiding blocks in Malaysia, according to the MS 1331 2003 standards. Line type blocks are served as an indication of correct route to follow, while dot type blocks are used to give a warning signal. Furthermore, we also made an analysis on the PICC reception counter and found it complies with the Universal Design Principle of acceptable height, but it is lack of wheelchair room beneath the counter. MS 1184 2002 Clause 24 stated at least part of the counter should be lower and constructed on the public side as a work surface for wheelchair user. The next topic will be the active and passive fire protection. According to UBBL 1984 by Law 168 guideline, every building should have at least 2 staircases. There are 10 staircases in PICC that surround the building's central point. Each entrance will have 2 sets of staircases, one on each side, leading to an open area. The remaining 4 are situated between the service area and the rest of the building, with a direct connection to the building exit. PICC uses a variety of appropriate fire-rated doors in the structure, with a fire resistance period of not less than half an hour, which made the UBBL by Law 162 and by Law 163 requirement standards. While every fire door must be marked with the words exit or keluar in Malay, as well as activated emergency lights, according to UBBL by Law 172. When the electric connections will turn off once the fire warning sirens are on, the emergency escape signal will offer sufficient illuminations to guide PICC user to a safe assembly place outside. Since the PICC is equipped with an active fire sprinkler system, exit from any portions of the auditorium must not exceed a 60-meter travel distance based on UBBL by Law 188. In addition, Bylaw 165 requires the travel distance to the exit must be measured on the ground or on a walking surface along the road center line. In a PICC plenary hall, the number of intervening seats between gangway is 14, and the exit doors are supplied along each gangway, which comply with the UBPL bylaw 184, to enable for effective evacuations of people. The seatway wide is designed to be uniform across the length of the theatre sitting rows. From the book, Guide to Fire Protection in Malaysia, we can see an example of continental seating configuration.
Moving on to the next topic, which is passive solar design and thermal comfort evaluations. So, sun path analysis provides a broader overview of suns and shadow falls on the site as the sun across the sky at different times during the days throughout the years. So 3 different months were chosen to carry out the simulations, which is on March, June and also December, and also 3 times, which is 9 AM, 12 PM and also 3 PM. So based on the result, the most exposure facade to the sunlight throughout the years is east and west side facade. So the main entrance of the PICC is oriented to the northeast, which avoid the direct sunlight. The building orientation is well determined by the shadings and it's a good practical application. Next, looking at the daylighting aspect, to prevent too much direct heat gain into the building, the cantilevered roof extensions works as shades to avoid more sunlight penetrations. So structurally it helps to reduce the direct heat gains, and also there's the features like recessed corridor and also the sunken space also applied in PICC to reduce the heat gains. So by observing on the glass facade, it is actually constructed at the angle of 15 degrees and to prevent the direct solar gain. The roof several stories also is designed to allow daylight into the building that enter from the above. So it will enable the buildings to gain sufficient daylight in the daytime while maintaining internal thermal comforts and also the luminance level. So the next aspect to be analyzed will be daylight factors. Daylight factors is the ratio of light levels both inside a space and outside a space. It is calculated using outdoor illuminance, which is the sky conditions, divided by the indoor illuminance to get the ratios. So which all of it typically measured in lux. As the result, the outer layer of the PICCs falls on the red zone, which approximately have more than 8% of daylight factors, which is stated uncomfortable and intolerable for a long stay according to the Malaysia Standard 1525. But since this area is covered with the outdoors corridor, it is still acceptable. So for the DF ratio is getting lower as it gets inwards. It approximately have DF ratio that lesser than 4.5%, which is acceptable and tolerable in the inner space. So overall, there's no perfect data factors percentage in a building. All we can do is have internal elements such as barriers or additional walls to prevent the excessive glare in order to increase the comfort level inside the buildings.
In conclusion, the PICC building integrates some complex systems in effort to achieve occupants' comfort and safety. With reference to MS 1525, UPPL and other related regulations, the building is proven to be effective in thermal comfort, sufficient in fire protection, and highly accessible to the public. Achieving occupants' comfort and safety in buildings is essential not only for energy efficiency but for the well-being of occupants as well. There are a lot of criteria in achieving comfort and safety as the requirements might differ from different buildings. Thus, architects must be aware of the required comfort levels and design accordingly.